about series clipper. I hope everybody understood that part. Any queries? What we discussed in previous class? Anybody have any queries? You can ask. Otherwise, we will go to parallel clipper. Objective is same. We have to save the waveform, or we have to if you want to clip a part of the signal without changing its original shape, so that is known as clipper circuit, and that can be realized uh, using diode components, resistor components, and additional DC sources. And series clipper, what we have seen, your diode is in series with respect to load, then that is known as series clipper. Now similarly, if you go for parallel clipper, so here diode and your load will be in parallel. So this is the definition, or if you design a parallel clipper, you have to design such a way that your diode and load will be in parallel.
Your PPT is not showing.
Yes, okay.
This call is now being recorded.
So if you see what I told, same thing. Your load and diode will be. So load means you can see RL is not given here because without that it's written V0, or either you can connect RL here. This is RL, you can also connect. If you are not connected, also it's okay, because output you are taking across the diode. So this is your parallel clipper circuit. So you can see first one, this this is your input signal. Now if you pass through this clipper circuit, parallel clipper, so this output you will get. Similarly for triangular, you are giving input, then you will get output, this one. So can anyone explain me how it is operating, or how you are getting this output? Anyone?
Sir, when the diode is forward bias, so the diode is short circuited. So the current flows to the diode, and across RL, no current, no voltage flows. So we get V naught is equal to 0. And when it is reversed bias, so diode acts as the open circuit. So then the current will flow through RL. So and we get that downward graph.
Any other one? Any other you can explain?
Current will flow through the path of the least resistance. So when the diode is forward biased, it flows through the diode. When it is reverse biased, it flows through the resistor or the load.
Okay. So already both they have explained. Once again we are repeating. Once again I am repeating. So how we are analyzing from the beginning? So we are considering positive half cycle and negative half cycle. Consider from 0 to 2 time period. This up, then you can see this will be plus and this will be minus. Now if you connect, then diode will be sorted. So now current will flow like this. Now here you can see whatever voltage across diode. Similarly, what is the voltage across RL? Both will be same. So now you can see if I'm taking ideal diode, so output will be, you can see it is output V0 is equal to approximately your Vk. So in forward biased, if I'm taking ideal diode, so Vd is equal to 0 volt. Sorry, V0 is equal to 0 volt. So which is shown here. For negative half cycle, it will act as a open circuit. So then you can take, this is minus, this is plus. So then diode will be in opens. Okay, now whatever current will flow, now current will flow across RL only. Now if I apply KVL, so here minus V minus V0 is equal to 0. So V0 is equal to minus V, or you can take minus Vm. So that's why whatever input you are giving, those are, you can see it is same waveform. Whatever in reverse bias, it is, you can see same shape it is generated at the output. Now here you can see a full half wave or a full half you are neglecting or you are clipping. So similarly, if you want to clip at part of that, then we have to take a additional voltage source. Accordingly, you can reshape, or you can what part you want to clip, you can optimize. Now here also, now for example, if I'm giving an input signal, so can you tell me what output I'll get? Here I'm taking, this is my input. So can you tell me what output you'll get? Anyone? Am I audible to everyone?
First positive nil, then again
Sir,
positive.
that positive half cycle we will get up to V, then constant, then again it will go
Yes,
down,
sir.
and the negative half as it is.
Once again repeat. For positive half cycle, what you will get?
Up to V, sir. Up to V, it will then become constant. Then when the voltage, means when the input voltage is less than V, it will increase up to V. Then at V, it will become constant. Then from again, when the input voltage is less than V, it will go down, and in the negative half, we will get it as it is.
So process you follow same thing for positive half cycle, the orientation of diode, same thing. What I'm telling, exam point of view to do. For positive half cycle, what you told, you can, now you can, for positive half cycle, so this is be plus, this will be minus. Now this, you can see this will be sorted. Now V will be there. Now here you can see, if it is sorted, and what output you will get, because this is parallel to the here. So here whatever voltage you are getting, you will get at the V0. So now this is, if I'm taking ideal diode, so it will be 0. Now at the output, what is the reflect, what you will get? So what is the DC voltage is here, same voltage you will get it here. So what is V, you will get here. Okay, for negative half cycle, what will happen? So it will be open. So so minus Vm will be, so this is up to V, and this will be minus Vm.
Yes.
This is clear? Something you are getting or something different?
Yes, same.
Yes, sir. This one.
So, but exam point of view, do step by step, then it will be better. Any problem, any circuit it will come. So unless positive half cycle, you give the sign accordingly, then you do it. So how I'm telling, you can see, you can write for positive half cycle or 0 to T by 2 time period, or for you can write now plus minus, and this will be sorted. Then what will be the my output voltage? You can apply here because V0 is equal to V. Similarly, for negative half cycle, that will be open. Then whatever current it will flow through the RL. So whatever voltage you are giving, VI, same thing you write in KVL. So V0 is equal to VI, and VI is at that time negative half cycle. This is minus VM, so it will reflect it that. Okay. Now if I'm here, so can you tell me what type of circuit it will be there? Now I want to achieve this type of waveform. So what should be my circuit? So if you compare in between series and parallel will be little bit easier. So it is up to you, because you can design same circuit. You can you want to achieve this waveform. You can also use series clipper, or either you can use parallel clipper. But parallel clipper is more easier, what I understood. Now, can you design the circuit to achieve this type of waveform? Anyone? Am I audible? Hello?
Yes, sir.
Tell me what type of circuit or you can achieve. Simple. If you understood earlier one, it will be more easier. Because earlier you got positive B. Here I have to get minus B. Then what is thing? The polarity of that polarity of the battery.
We have to
No. Diode will be same. Polarity of the battery you can battery you can change. Are you getting me? So only you can change the polarity of battery. So then you can achieve, because in positive half cycle, whatever output you are getting based upon the battery only. So now if I will change the polarity of battery, so it will give you minus V. And in negative half cycle, minus Vm will you will get. So that's why only you have to see battery orientation you are changing. Compare here, minus V I'm getting.
Sir, can you explain this again?
Okay. Now, because we have to design a circuit where I should get in positive half cycle minus V, and in negative half cycle it will be minus Vm. Now here you can see in positive half cycle I should get V, or whatever voltage I have to get, so that you are getting due to the battery supply. Okay. Now if you see the previous case, now if I'm using battery here, so whatever battery voltage is there, it is reflected on the positive half cycle. So here also I have to achieve minus V. So then if I'm changing the polarity over here, minus V I'm doing, or either I am changing the polarity, so I'll get minus V. Because in positive half cycle, what you are getting, for positive half cycle, what we are getting, plus, minus, resistor. Now this is sorted due to the sorted. Now whatever supply voltage you are giving, so it should be reflected, because this is your output, na? So V0 will, whatever V0 will get, whatever supply voltage you are giving. Now if I am taking positive power supply, here I will get positive. If I will take negative, minus V, so it will reflect it here. So for this case, I have to achieve minus V. So I have to check, I have to take a battery supply, which will be this one. And in negative half cycle, anyone?
The graph that you're drawing, is it different for positive biased and negative biased? Like the same graph we get, or some different in parallel clipper one?
Because this is because I told in parallel clipper easier to series clipper, because your output is, you can see diode is parallel to load. whatever voltage will be getting here, it will reflected the output. So both are more. Whatever.
Yes, sir. So, like the same graph we can get obtained after we give it forward bias or reverse bias. Like the same graph we get. I'm not talking of polarity, just the biasing one.
Here, because I want to achieve minus V, na? Here I have to achieve minus V. How to achieve that one? So this is okay. You are you confused? You have started like this. Here it is started like this.
No, sir.
Then
No, sir. I was just asking. You said na you just change the polarity, then you're getting this one.
yes, that you can see here your output. Here your output is depending upon what battery supply you are taking, because this diode is shorted. There is no voltage, so output only depends upon your supply voltage. So now
Yes,
if
sir.
you want to see your output voltage is positive V or negative V, so depending upon the polarity of the this is supply voltage. And also whatever quantity you need, for example, I need 2 volt, so I have to use a 2 volt DC supply voltage. So it is
Yes, sir.
generalized, for example. So if you see the circuit circuit diagram, so here you can see only this V is changed, polarity is changed. Now you can go through all the diagrams it is given in your book also. You can see, for example, the circuit, once I repeated, same circuit. So I want to get positive V, so V is here. And in negative half cycle, because all the current is flowing through RL, so whatever input you are giving, it will reflect at the output. So minus VM you are getting, only you are controlling in the positive half cycle, which is depending upon your supply voltage. So these two are we have discussed. Now coming to third one. This one you can see I want to clip both sides. So now you can see positive V and this is V2. So accordingly I can give V1 and V2. So both sides you can clip. So if you understanding, you can see for positive half cycle this is sorted. So whatever V1 you will see, you will get across V0, and positive half cycle it will be open, and you will get what is the voltage V1. Similarly for reverse bias, it will be open and this will be sorted. So whatever V2 you will get in negative half cycle. Similarly, if you want to change the diode orientation, now you can see in negative half cycle, for positive half cycle you can see, for positive cycle it is open. So now current will be flow through RL. So that's why positive half cycle you are getting maximum VM. For negative half cycle, this is sorted. So whatever battery supply voltage is there, you'll get same thing. So your battery supply voltage is minus V. So you are getting minus V here. Now similarly, if you can see for negative half cycle, I'm taking positive V. So you are getting here positive V here. Is it clear, or any clarification in particular circuit you tell me? Step by step I will do it. Clear? Or any circuit you want to once again have to repeat, let me know.
Sir, the last one.
Okay. So for I'm writing for positive upcycle. Okay. So what will the circuit? Now this is plus, minus. Now I'm taking R. For positive half cycle, this will be open. Diode is reverse bias. This is plus, this is minus. So it will be open. Okay. Now whatever voltage you are taking, this is will be repeated. So this will be V, and then RL will be there, which is equal to. Now you can see current will flow because this is open. So this won't work. So it will be like this. Now for positive half cycle, V0 is equal to whatever input you are giving, it will reflected there. So V0 is equal to Vi, and which is equal to your Vm. Clear? Am I audible?
Yes, sir.
Yes, sir.
Similar for negative half cycle. So once again you draw the circuit. Minus, plus, resistor, then diode will be sorted. Now what is the voltage here? You have taken V. Na? So it's okay. Now here you are taking V0. Now negative half cycle, what is the output? So V0 is equal to what is parallel to this line, so which is equal to V. So negative half cycle, you are getting V0 is equal to V. So now you are getting V0 is equal to V, negative half cycle. Clear? So for positive half cycle, you are getting Vm. For negative half cycle, you are getting plus V.
Yes, sir.
So for each circuit, you do a similar process. For positive half cycle, what is happening? For negative cycle, what is happening? Accordingly, you can apply KVL and you can see the output. Okay, any additional clarification required? Please tell me. So remember, any type of waveform is given. So you can also design the circuit. If you understood clearly, you can also design. Or sometimes circuit will be given and some input will be given. Accordingly, what output you will get it. So to this type of problem may be asked in exam also. Okay, so application of clipper, if you see, so one part half wave rectifiers, total one part you are clipping. So generally it is used for wave shaping circuits. And third one, you can say clippers can be used for as voltage limiter or amplitude selector. So you can see you are controlling or you are selecting a voltage. So you can this type of circuits mainly used in receivers, TV receivers or FM transmitters, where you are detecting the amplitude. Clear? Any queries in clipper part? So clipper part is over. Okay, respond your ID numbers. Then we'll go for clamper circuit. First, let me See how many are attending. So ID number 1.
Sir.
6. 11. 12.
Yes, sir.
But I am getting minus 2V here. So this V is shifting. This amplitude, you can see total amplitude will be same. V to minus V is there. So total voltage swing is how much? If I am taking this is your input signal, can you tell me what is the voltage swing?
2V.
2V. So you can see this output, or we can see I have to achieve this amplitude 2V. So logically, if you see logically, so if I'm taking this line, I'm taking this origin is here. Now I'm taking origin to this position. Okay, so this I'm taking 0. So automatically this will be V and this will be minus V. So what we are doing here, you can see this is your DC level. Now only we are shifting the DC level. Or you can see this DC level we are shifting to this position to this position. Are you getting me? So this DC line or DC offset you are changing. Otherwise voltage swing will be same. So clamper circuit, if you see clamper means which does clamping. So you can do up clamping or down clamping. So similarly you can see we are doing down clamping here. So a DC offset level you are moving downwards. So this type of circuit is known as clamper circuit. Now to achieve, now you can see this is your input and this is your output. Now you have to do that. Now what type of design or what type of components are required to do this process? So if you see here, compared to clipper circuit, here you are additionally using a capacitor. Otherwise resistor, diode or DC supply voltage we can take. Additionally this capacitor is used. Now you can see why capacitor is used. Already you know it is storing the charges. So for certain during on period or off period, so this capacitor will store the same potential which later on you can utilize to achieve the desired amount of voltage. So ultimately the definition you see, clamper circuit, a clamp a signal to a different DC level. So here you can see DC level we are shifting. So you can also this shifting you can do upward also. And the network must have a capacitor, a diode and resistive element. An independent DC supply is used to introduce additional shift. Now remember this, whenever you are analyzing, so the circuit is right or wrong, you can decide based upon this condition. Total swing of the output is equal to the total swing of the input signal. So here total swing will be 2V, here also total swing will be 2V. That means it is you are doing or circuit is a clamper circuit. So depending upon the orientation of diode or shifting of the DC level, you can classify it can be a positive clamper or negative clamper. Now can you tell me the circuit what I have shown, this is a positive clamper or negative clamper?
Negative clamper.
Negative clamper.
Yes. So this is a negative clamper. So this orientation of diode you can see this is you can see the orientation of diode is like this. Now if you go for negative clamper, the diode orientation will be changed. Now we'll go for analysis part, how it is doing clamp DC shifting. Now we'll analyze this circuit based upon the clamper circuit and what are the steps are followed. And same step you can follow any type of clamper circuit. So this is so first so first you remember to charge the capacitor. For example, charge the capacitor, the diode should be in forward biased because then circuit will complete, then capacitor will be charged. So diode on and the capacitor charging to V volt. So based upon input supply voltage how much it is, so capacitor will charge up to that maximum voltage level. So if I'm giving V, so capacitor will charge up to a V voltage. And already you know capacitor discharging which the time is 5 times higher than your charging time. So during this discharging time also, if you see the voltage will be remain maximum voltage will be remain up to V volt. So first condition you can see capacitor should be charged. When capacitor should be charged, for this condition you can see diode should be in forward bias condition. So at that time the circuit will be complete. So internal circuit will be complete. So now you can see capacitor also will be charged up to V volt. Now determining V0 when diode is off. So now when diode is off, so what will happen? So this current, you can see this current will flow through the load this resistance. So now you can see if I'm applying KVL, so V, so this is V minus V0 is equal to 0. So here you can see 0. So here you can see you are getting 2V voltage. So here for positive, once again I'm repeating, for positive half cycle what is happening? Now here you can see for positive half cycle, now this is plus minus, so plus minus, now this is sorted. Now for positive half cycle what is happening? This capacitor will be charged. So how to find out the capacitor charge? Now for example, this is, you can see this capacitor, if I'm applying the KVL here, so here we can see V minus what is the voltage here you can see V minus what is the voltage at the capacitor is equal to 0. So CV is equal to V. So what is the voltage across capacitor during the on condition? It will be V volt. Now when you are applying the negative half cycle, so negative half cycle means this will be minus, this will be plus. Now already capacitor is already, this is already V. Now in reverse bias condition, this diode will be open. Now whatever current will flow across this one only. So if I am applying KVL here from bias condition, so what will be there? So 0 minus V minus V minus V0 is equal to 0. So V0 is equal to minus 2V. So this is for negative half cycle. This is equal to minus 2V. So for positive half cycle, what will get? So V0 is equal to now V0. You can see parallel to this resistance, which is parallel to your diode. So which is equal to voltage across the diode. So if I am taking diode voltage, so it will be 0. So for positive half cycle, you will get 0, and for negative half cycle, you will get minus 2V. Are you getting me? So if I am using this Kumar circuit, so for positive half cycle, you can see voltage which is parallel to your diode, and diode voltage you know for ideal diode is 0 volt. So positive half cycle it will be 0 volt, and for negative half cycle it will be minus 2V.
Sir, for positive half cycle, why it is 0? Can you explain again?
Okay. So you can see V0 is across this one. Okay. So V0 is across this one. So now you can see this diode is parallel to R. So here whatever voltage you will get, which is equal to the voltage across the diode, because you know, because when I am taking parallel, so voltage will be same, na?
Yes, sir.
So now you can see across the diode, what is the voltage? Is equal to 0 volt, ideal diode. If I am taking a silicon diode, then 0.7 volt. So but here if you see, this is taken ideal diode, so that's why it is 0. So
Yes,
in exam point of view, it is given silicon diode, so then you can take 0.7 volt. Remember, for germanium or silicon, this is given, so accordingly this value will be changed, and this will be changed, and this will be changed. Are you getting it? So this will be minus 2 volt plus 0.7 if I am taking silicon volt. So apply same formula. Are you getting me?
Yes, sir.
So same process you have to follow for positive half cycle. What is happening? Remember, in positive half cycle, capacitor is charged, and whatever voltage you are getting, which is parallel to the diode. So this is the step for positive half cycle. For negative half cycle, you have to see, because negative half cycle supply voltage and also what is the stored voltage in capacitor, and this current will flow across your this resistance, and this diode will be act as open. Okay, so in Kumar circuit, you have to see, or you have to take that cycle when your capacitor will be charged. So then we'll see the steps. Whatever I told, all the steps one by one, it is written. So first you can see, start the analysis of clamping networks by considering that the part of input signal that will be forward bias the diode. Why it is given? Because diode should be on condition, then current should flow, then capacitor should charge. So that is the objective. Second, during the period of the diode is on state, assume that capacitor will charge up instantaneously to a voltage level determined by the network. So that voltage, whatever input voltage you are, the capacitor will charge up to that voltage only. Third one, assume that during this period the diode is in off state, the capacitor will hold onto its established voltage level. Throughout the analysis, maintain a continual awareness of the location and reference polarity of V0 to ensure that proper levels for V0 are obtained. Last point, keep the mind in general rule that total swing of the total output must match the swing of the input signal. So 1, 2, 3, 4, whatever steps we were following, and you are achieving the output waveform. Testing condition is voltage swing of the input signal should be equal to the voltage swing of your output signal. So these are the 4 steps you have to follow. And 5th point is for checking whether your clamper circuit is a pure clamper circuit or it is a clamper circuit or not. So we'll take another example. You can see. So can you tell me if I'm giving input signal? This is already we discussed. This is your input signal and the output signal will be this one. This is we have done. Once again, I'll repeat it or you understood it?
Yes, sir.
Okay. So next you can do it. This one. Take a square signal. No problem. Take a square signal. What will be there? For example, this is your input signal. So what should be your output signal? This is also given in your book. You can refer that one also. Or can you tell me what will be the output? Okay, can you tell me for example for 0 to t1 time period what will happen?
So 0.
0 to why 0?
So because forward bias and it will short circuit.
So 10 volt you are giving. Okay. So this is 10 volt. So I am giving plus and minus. So what will happen? What will be 0 volt?
Sir, 10 volt it will be.
Yes, at 10 volt. It will remain 10 volt.
How can you tell me? 10 volt? So tell me how it will be there, 10 volt.
Sir, diode is not, diode part will short circuit and it will flow through load part.
How does it be short? So this is you are giving positive.
Sir, not
negative.
short,
So
it will be open. Diode part will be open.
Okay. So this will be open. Okay. Open. Then?
Sir, it will flow through the load part and it is parallel, so this will be 10 volt.
5 volt. 5 volt you are telling, no? So this is open, no? So you are telling 10 volt will flow through the here. But in your capacitor you are using, no? Capacitor, you know, this is a parallel plate. Capacitor, then it won't allow the flow the current, no? Still it won't charge. So initial stage capacitor is not charged. So then how circuit will complete?
So the capacitor will be charged to 5 volt, and therefore the overall voltage will be 5 volt.
For charging the capacitor, so this diode should be non-state, na? For example, this capacitor will charge. When it will charge? When this will be a closed
When
path.
V in will be greater than 5 volt, then the diode will be on.
Now that's why if you see for 0 to T1 time period, so this because it will take some time, you don't know how much time it will take. So if you take ideal condition for project 0 to T1 time period, this output will be 0 because it is act as a open, because capacitor till now it is not charged. So first condition what I told, capacitor should charge, then the circuit will operate. So that's why for 0 to T1 time period, diode is open. So that's why this capacitor won't be charged. So when diode is be shorted, at that time capacitor will charge. So when diode will be short, this diode when it will be short, when it is reverse biased. So reverse biased means you can see during this time period, T1 to T2 time period, or if I'm taking minus 20 volt, at that time the capacitor will be charged.
Sir,
This will be
sir,
sir,
from 0 to T1 time also the capacitor can charge because the current will flow through resistor R and thus the circuit will be completed.
No, that R1 you are taking as the output, na? For example, I am not taking this one because this R or this will be connected parallelly, na? For example, I am not taking R because when you are using a multimeter, I can use the multimeter here because R is not connected. To capacitor charge, this should be a complete path. Are you getting me?
Okay, sir.
So this R I have taken here. For example, I cannot this R you cannot take also because this is load. No? This load component you are using to measure your input voltage, to measure the output voltage. If not using RL, then circuit will complete.
No, sir. Then it will be 0.
So for example, for your clarification, R is not given.
Sir, can we say that R is very large, so the capacitor will be negligibly charged?
No. The R is taken in a circuit because you are taking a load resistor. Load resistor across the load you are measuring. For example, I am not taking the load resistor. I can directly use multimeter across this point to this point also. No? Because when I am using a voltmeter here, so I can connect here. Because voltmeter already have internal resistance, which will measure here. So to charge the capacitor, this branch should be short circuited. Are you getting me? The branch should be a complete path. Don't take R to make capacitor charge. So this branch should be in such a way, we have to arrange such a way that the current should flow in this region. Now how it will make when diode will be in on condition. And when this diode will be on condition, when I'm doing this reverse bias condition, because diode orientation is in this direction. If it was in this direction, so there is no problem. Earlier case you have seen for positive half cycle, the capacitor will be charged. But for this case, this is diode is in reverse bias condition. So to make it on condition, this will be only possible in
Sir, in forward bias condition also the diode can get short circuited if V in is less than 5 volt.
Which one?
If V input is less than 5 volt, then also the diode can get forward bias now.
Here you are telling this B in. This B in, what you told once again?
Less than 5 volt is when it is less than 5 volt, like 4 volt or 3 volt, then also the diode can get sorted.
Do it. Apply the KVL. You see how much you are getting. But the capacitor you have to charge up to the what is the input voltage? Because why you are making it conducting path? because capacitor to charge up to what input you are giving. So if I'm taking less than V, then capacitor will charge. So that's why input, how much input you are giving, that should be flown through the capacitor, and capacitor should charge up to its peak level. So for this condition, you can try for that. For input, you can vary, but here this question is given. Here you can see what is given here. This voltage is given. My point is, during 0 to T1 time period, there will be no output, but during this T1 to T2 thing, so it will be sorted. Then what will be the output? So now during this T1 to T2 time period, T1 to T2 time period, so minus 20 volt, minus plus, so this will be act as a short circuit. Okay, so what is the output you will get? What is the output you will get?
35 volt.
How you get 35 volt?
So 20 volt input, then 5 volt from 20 volt from 10 volt from capacitor and 5 volt there.
No, sorry, you forgot in parallel clipper what I told. V0 is parallel to this one. Because in negative half cycle it will be charged. It will charge. But what is the V0? What is the voltage across this node to this node? And it is sorted. So whatever voltage you are getting, which is equal to V. For this half cycle, you will get V0 is equal to V. And for this half cycle, you are getting 0. So V0 is equal to 0. And here you are getting V0 is equal to V. Okay. These 2 points you understood or not?
Yes, sir.
After that cycle, you can see it will be charged. So now during this condition also, you have to find out what is the voltage across capacitor. Next step is, what is the voltage across this capacitor? Okay, your class time is already over. So next class we'll discuss this part once again. So you can go through the book and you see that part. Also, next time we'll discuss in more detail. You have any other class now or don't have? Hello?
Now is the lunch break, I guess.
Launch time, sir.
Okay.
So are we having BELE lab now?
Today?
Today is the lab is there, no? At 3 o'clock
Yes,
maybe?
sir. Yes,
Okay,
sir.
okay. Only 1 minute. Okay, only 1 minute I'll keep and then we'll leave. So here, so you can see here for positive 0 to T1, you are getting no. And during this period, you are getting 5 volt. Whatever battery supply is given, you will get. So this is your 5 volt. Now in third half cycle, T22 by T3. So what will happen? T2 to T3. So what will happen in T2 by time? So now in this time period, what will happen? Now this is 10 volt. Now this will be plus, minus, plus, minus. So this will be 10 volt. 10 volt. PPT is visible to everyone? Hello?
Yes, sir. Yes, sir.
Okay. So this is color is not in little. So this will be plus minus 10 volt. Okay. So for T to T by 3 time period, so this will be plus 2 plus minus 10 volt. Now this will be open. Now current will flow across across your load, what you told earlier. Now what is the voltage across the capacitor, which is charged during your T1 to T2 time period, that you have to find out.
So 15.
So apply the KVL. So you can see the diagram. Now you can see, because this is sorted, you can see minus plus 20 volt. So VC we have to find it out. So VC is equal to apply minus 20 volt plus VC minus 5 volt is equal to 0, and VC is equal to 25 volt. So this is your achieving during T1 to T2 time period, when your diode is in conducting region. So this is, you remember, this point is very important. When capacitor will be charged, only that period you have to find out what is the voltage stored in the capacitor. So now you can see this capacitor will charge in every time, in each time period when the in conduction region. And you can see discharging time is very higher, because one cycle it is charged, other cycle it is not charged. But this store, because discharging time is very much higher compared to your charging time. So during that cycle, when it is not charged, but capacitor has that potential, so that we have to consider. So now here you can see this 25 volt is available across this capacitor. Okay, this is you are getting in between T1 to T2 time period. Now we have to apply this in T2 to T3 condition time period. So T2 to T3 time period means at that time capacitor will be, you can see capacitor is charged, but this will be in off state, because T to T3 time period, this is plus 10 volt only. So this is plus minus 10 volt, capacitor is minus 25 volt, and you can see this is open. Now here you can see the circuit will complete like this. Now what is the output? You will get it here. So apply the KVL. 10 volt minus 25 volt minus V0 is equal to 0. So V0 is equal to 35 volt. So that's why in T2 to T3 time period, you are getting 35 volt. So once again, the same diagram is there. You can compare. Now you can see voltage swing. What is the total voltage swing? So here is 30 volt. Here also you can see voltage swing is equal to 30 volt. So that means the circuit is a clamper circuit. Now if you are considering the practical diode, so accordingly the value will be changed. So if I'm taking silicon diode, so accordingly 5 volt you are getting here, so you will get maybe 4.3 volt. Is it understood to you? Any doubt, anything?
No, sir. Understood.
Okay, then it's okay. We can stop it here.
Sir?
Please.
So in 0 to T1 time period, why capacitor is not getting charged?
So because 0 to T1 time period, you can see this is in positive half cycle, but diode will be in off condition, because if I'm taking plus 10 volt to minus, you can see here. So this diode will be on, because this is, you can see here, this is plus.
Yes, sir. So, but the current can flow through the load resistor, na?
That's you're telling, but at the time also capacitor is not charged, na? So this act is open also, the circuit is not complete. The initial stage, capacitor also is not charged. So there will be no flow of current here also, na? Because to complete the path, capacitor also should charge, or it should allow to flow the current. In initial stage, capacitor is not charged, so that's why it is not the circuit is not complete. Is it okay?
Yes.
So that's why in first thing is you have to charge the capacitor. When it will charge? When the circuit is complete. Now for this condition, this is complete when negative reverse bias condition, when you are taking T1 to T2 time period. At that time it is completed. This is sorted, then current will pass through this. So this period is okay. Okay, so other circuit you can also see in your book. It is given. These are given. If I'm taking positive diode, I'm taking practical diode. So this will be the values. So these are the circuits are given, and you try to analyze all the circuit. So next class we can discuss any doubt in that. We will discuss. But go through this circuit and you apply what logic we have applied, and try to solve those. Okay, so we can stop it here. So you can leave.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.